All right, so me and Gajesh are back with another Infinite Layers. Today we are interviewing another ABS team, Brevis. So without further ado, do you mind introducing yourselves about not only yourselves, about the company as well?
Sure. Yeah. Well, first of all, thank you for the kind invite, Nader and Gajesh. I'm Mo. I'm co-founder of Brevis. I'm also previously co-founder of Stellar. So I've been working in the blockchain space for quite some time. But before that, I did my academic life in UIUC, got my PhD in computer science, focused on distributed systems and networking. And for Brevis, what we do is essentially trying to introduce the asynchronous architecture in the blockchain application building space to basically to put it simply, to allow your smart contract to be supercharged with ways to actually read historical on-chain data such as events, transactions, and states, and do arbitrary computation on top. And your smart contract will be able to use that data in the smart contract directly without any trust based on any third-party services. So we use zero-knowledge proof to achieve that trust-free nature of our protocol. And that enables a very wide class of new type of applications that it can be built. And very uniquely, we actually work closely with EigenLayer to build out this unique architecture that combines crypto economic security and ZK proof together, which we are definitely going to talk more about today. So yeah.
Hi, I'm Junda. Sorry, my voice is a little bit weird. I'm still having a bad cold from the kid. I work with Mo on Brevis, and previously we worked together on Stellar. And I think, if you are a DApp developer, we're always joking the smart contract is not smart at all, right? What can you do within your smart contract? It's actually very, very limited. I think Brevis kind of comes in and said to fill this huge gap that, all the people talking about the gold mine of historical on-chain data. Now, inside your smart contract, you can have a trust-free way to access, both the data and also whatever the insight. When Mo says arbitrary computation, right? It's more like based on the data, what are the insights you can get and how the insight can drive and make your DApp better. Yeah. Mm-hmm.
So when you all decided to build Brevis, what were some of the things that kind of led up to it in terms of why you chose to build this specifically?
Yeah, well, I think it's really when it comes to motivation, I think we really start to see that no matter how much we scale the entire blockchain ecosystem and architecture, it's still very much limited as a synchronous based architecture where you have different users that are essentially just treating the blockchain as a single server, and this single server actually does it all: data access, compute, recording of the state transition, everything. Right. So, but this is not really how web is built today. Like in modern internet is not built like this. Modern internet is actually built based on an asynchronous architecture, where the web server itself is just the same piece of coordinator that is coordinating between different pieces of specialized services, such as big data, machine learning, recommendation system, and all of that. So, we think that, Web3 in general is also going to move towards that, where the blockchain itself is just acting as a coordination layer and a very thin layer that is essentially be able to handle high concurrency requests from users, but offload a lot of computation out to specialized off-chain computing services, and then let these off-chain computing services to return results back to the blockchain. So this is the architecture that we think makes a lot of sense for a lot of different kind of use cases and applications. And we actually hear this from many of our existing partners, even when we were still doing Stellar in the Stellar days. So that's that's kind of like the motivation we came up with Brevis basically.
Yeah, would you consider this something like how when we're talking about the modular thesis and decoupling all these different pieces, we
Right.
originally kind of saw the first part of the stack that was driven by data availability with Celestia at first, and that was kind of like a big story, like decoupling that and being able to kind of have these separate pieces. Would you consider that this is a similar story in terms of like where the industry and where the I would say architectures are going to be headed in the future?
Yeah, definitely. I think the key thing we're trying to do here is generalized option verifiable computing. That is like, you put a lot of computation of the blockchain to some specialized and highly performant computing services, but at the same time, not just computing the result itself, but also generate a zero-knowledge proof so that the entire computation cycle can be verified on chain. The nice thing about this is that the blockchain, from a kind of a smart contract perspective, the blockchain can just directly use that data or use that computation result without adding any additional trust other than to the blockchain itself, right? So that's kind of like where we're trying to essentially decouple many of the complex and data-heavy computation out from blockchain into a modular stack that is in charge of doing that specifically.
Okay, great. Well, I have quite a few questions, but I'm curious that a lot of these might be answered in the presentation that you're about to give.
Yeah.
So let's jump into that, and then when we're done, we're probably going to do a nice Q&A. First of all, I'm going to ask you questions specific to Brevis, but I also want to kind of talk about just building on EigenLayer for other AVS developers. Sure. So is it cool if we go ahead and get that started?
Yeah, let's get that started. If you could pull up the slides. Yeah, awesome. So yeah, well, as mentioned, like Brevis is really trying to introduce the asynchronous architecture in blockchain, and we're essentially trying to build the engine of Web3. So what do I mean by that? What is like asynchronous architecture, in general? Like Web2, before we kind of talk about Web3, let's talk about internet, like, or web as we know today, right? So web architecture before 2000 is actually built on this type of synchronized architecture, where when you have users starting to send user requests to web servers, these type of requests are always handled one at a time. And there's a monolithic server that does everything a user request entails, like request handling, access control, authentication, computation, data access, read, write, and storage, and all that. And it was very obvious that this type of architecture is unable to scale as the user amount of internet scales. So very quickly, the entire internet world or the entire web architecture converged into this new one, which is a asynchronous-based web architecture, where the web server is actually becoming a very, very thin layer. It is just doing the very, very essential things to handle, concurrent user requests. And it is not actually doing a lot of work, but it's actually offloading and coordinating between different specialized services. So let's say when you're going to Twitter, the web server you hit is not actually kind of doing the fulfilling of your information feed or doing the authentication. Everything is then offloaded to specialized services that in asynchronous calls. They essentially send message to say, okay, this user wants you to do that, go do this. And these specialized services, when completing these type of specialized computing, data access, and all that, will return the result as callbacks to the web server. And the callbacks are essentially also messages passed from these specialized services to the web server, carrying the processing results. And the web server, after receiving the result, will return it to the user and essentially present user with like whatever the interactive flow the user is now experiencing in every single Web2 services we use. In fact, every even things like Google, YouTube, Twitter, every major web services you can think of today is built on this type of architecture. Now, if we look at Web3 today, which is like blockchain, the app ecosystem, it is actually worse than Web2 before 2000s. So it is very much a synchronized architecture for sure, because right now, if you think about it, the blockchain itself is the web server, Web 3.0 server that handles everything. But the worst thing is that it is actually providing just a very, very limited kind of computation you can do, and with very limited capability to do data access. Because the entire smart contracts ecosystem are running on blockchain, and blockchain is essentially a replicated computing and storage with huge networking overhead due to the consensus protocols involved. So to make a very, very simple example, right? So let's say we want to do a trader loyalty program today on Uniswap. The idea is very simple. You see this type of thing in every centralized exchange, where if you traded more than 30 million volume in last 30 days in some exchange, in the next 30 days, you become this qualified VIP trader. In the next 30 days, you get a 50% trading fee discount. This is the type of feature you see in every centralized exchanges. But you don't see this type of thing in any DEXs today. Why is that? Well, precisely because what I mentioned. Doing this directly on blockchain, even just to compute a user's historical trading volume directly in the blockchain smart contract today, even just for one single user, takes 4 hours and 20K in transaction fee, just with like this sample user. Now, why is that? It is because that blockchain in nature, today doesn't really have the capability to do this type of a data-driven computation on blockchain today. Even though smart contract is living in blockchain, it doesn't have trust-free access to historical on-chain data. It doesn't have trust-free access to data on other blockchains for sure. And in general, even if the data access is there, it is bad at data-driven and very complex computation to do things like parsing the LRP, of the transactions and adding up the transaction volume directly on chain. So this is why this type of feature or this type of any type of really data-driven feature doesn't really exist on blockchain today. So we're trying to introduce the asynchronous Web3 with Brevis, where the blockchain itself can just purely focus on the transactional computation involved in asset movement, asset exchange, where you actually absolutely need to have read access and write access to this publicly accessible ledger, but offload a lot of the computation tasks, in many cases involving like why these type of asset move happens, to a coprocessor, which actually handles the data-rich and complex computation that returns the result. Of course, the very important thing here is that this entire architecture should not introduce any additional trust in the computation cycle other than the blockchain itself. This is why we introduced Brevis, and Brevis you achieve this by be able to by generating ZK proofs for arbitrary computation on really any data. And because it can do that, it now allows smart contracts living in the blockchain to utilize these type of computation results generated on chain in an entirely trust-free way. So using Brevis today is actually very simple. We have a very, very easy to build SDK. Even though it is built on ZK technology, you don't actually need to understand ZK circuit building. From a developer point of view, there are really just 3 simple steps. First, you need to specify what type of data you want to read from the blockchain. So we now support things like storage states. This include any type of kind of on-chain states of variables, such as NFT ownership, such as token ownership, such as like anything that related to the variables stored in the blockchain smart contracts. And also transaction receipts. These are the these are the things that stores events essentially, such as if you make a trade on Uniswap, there will be event emitted, and the event is actually going to be contained in a transaction receipt. And the transaction itself that contains the transaction lifecycle, whether the transaction is successful or not, whether there will be a failed transaction reverted, what is the result of the transaction, who sent the transaction, all of that. And of course, there are a bunch of other things like block information, beacon chain state account information on all these supported blockchains. So, this very simple code sample basically shows that how you can do transaction, add, data related to a user's historical trade on Uniswap in the last 30 days. It's a very, very simple code base. So the second part is really compute. We provide a very, very easy to use data stream based API where in the first step, you collected a bunch of data, right? So like you collected a lot of historical data on chain. The second step is how you want to do computation on those data. And using this data stream API, you can apply map, reduce, filter, group by this type of primitives with arbitrary computing, computing functions on top of these primitives, such as you can filter whether this transaction is coming from this guy, whether this transaction is matching certain type of criteria, and you can apply map to kind of transform some of the data in the transaction. You can use reduce to calculate the sum, average, variance, volatility of a price feed, and so on and so forth. And this very simple example here basically shows you how to calculate a user's trading volume on Uniswap in the last 30 days. Very, very simple, just 3 lines of code. And finally, after the computation, you can feed that data back into the blockchain and back in the smart contract where you can drive your smart contract logic based on the computation result generated from the historical on-chain data.
So do you mind if I jump back to slide 15 real quick? I just want to go back. I have the control real quick. I just want to see.
Yeah, okay, sure. Yeah.
So the flow starts here. Is this Go?
Right. Yeah, right. Yes. Yeah, this is a goal. We now have 2 sets of different SDKs. So one is Go-based SDK, the other is JavaScript SDK. This is basically the same thing. We're just showing a Go code here. But yeah, you can kind of use whatever SDK you want.
Very cool. Sorry to interrupt. Go ahead.
Yeah, no problem. So yeah, so this is what we do. And with Brevis, let's come back to that example of trading volume-based fee discount, right? So with Brevis, doing the same thing is actually going to be insanely cheap. Proving a 1,000 transaction to calculate the volume is just going to be $1.8 in computation cost, and the latency of doing that is just 144 seconds. So in general, even with to put that into context, Uniswap on a monthly basis generate about 4 million trades, and with just 8 cards of consumer grade GPUs, we can handle way more than what Uniswap generate on a monthly basis. So this basically demonstrates that Brevis is very much ready for production. This is why a lot of the top DeFi partners we work with now choose Brevis to build many of the data-driven DeFi features. So now let's talk about a very, very unique thing about Brevis. This is where we actually combine the power of crypto economic security and ZK proof by using eigenlayer. So in some cases, and the developer may not want to do upfront ZK proof generation, because ZK proof generation does carry a certain amount of latency and also carry a certain amount of cost. So if you want to get away from that cost entirely, what you can do is to use a new model, a very, very unique model that only Brevis has, which is Brevis coaching. So the idea of Brevis coaching is very simple. Instead of directly sending a co-processing request or kind of this type of computation request from a on-chain smart contract to an off-chain ZK prover network, the co-processing request gets sent to an AVS powered by eigenlayer. So the Brevis AVS, the node operators in the Brevis AVS will now be able to generate a crypto economics validated result by individually computing based on the co-processing request. And this result, once reach the quorum, will be able to submit it on-chain. But once this goes to on-chain, it will actually trigger a challenge window. So, the challenge window is where the ZK actually combines with crypto economic security. If in the sense that if the result is actually incorrect, we can have a group of challengers initiate the challenging process and submitting a naysayer ZK proof to basically say that, hey, I can generate a ZK proof now, after the effect and show that this crypto economics validated result is incorrect. And, whenever the slashing is enabled, the node operators themselves can be slashed. Right now, the slashing is not enabled, but we'll be able to essentially kind of ban some of the node operators from participating in the ABS in the future as kind of the first cut to ensure crypto economic security and fall back using the ZK proof, the ZK naysayer proof. So the benefit of using this is not only the cost reduction, but very importantly, two more things that I want to mention. One is that this architecture actually offers a security level that is stronger than simple crypto economic security, because that even if a quorum of more than 2/3 of the node validators colluding or acting in a faulty way or malicious way to generate a wrong result, the result can still be corrected using the ZK naysayer proof. But in pure crypto economics based systems, if you have more than a quorum of node that is just acting in a faulty way, then there's no redemption from that. The second point that I want to mention is that this is not just for security and cost, which are already both important, but also about features. So using this architecture, you can do some features that is just not possible with the pure ZK solutions. So, one notable feature is the proof of non-existence, right? So if you want to prove that a user never actually traded with Uniswap, to do that in pure ZK, you actually need to prove the entire block history on Ethereum blockchain to prove that, okay, among all and every single transaction ever existed on Ethereum blockchain, there's not a single transaction between this user to the Uniswap smart contracts, which is of course infeasible, in practically speaking. But using this type of proposal plus challenge based model, making this type of a proof is very simple, where you can just directly propose on chain saying that, hey, look, I'm now claiming that there isn't such a transaction, but if there is, then the naysayer ZK proof to challenge that the crypto economics validated result is very simple. You just need to find one single transaction that exists in the past to kind of challenge that and invalidate that crypto economics results. So, this is a really unique architecture. We think that it's not only just going to apply to what we now focus on is data processing, data access and database computation, but in the future, arbitrary computation and things like machine learning on chain are all going to benefit from this type of architecture. We're also expanding towards that as well. So there are a lot of very exciting use cases that you can build with Brevis, because now you really have historical data access. It's almost like you suddenly have true database access to the entire history of blockchain in your smart contract, and there are numerous things you can build with that. So data-driven DeFi is the most typical one that people immediately comes to mind, right? So because DeFi apps, they have a lot of data such as LP deposit, swap event, the liquidation, price data, and all that. And these generated historical data can be used to derive very important insights. And using these insights, we can dynamically adjust the protocol parameter configurations. Right, so things like trading volume-based fee discount is just one example. There are a lot more that is being built by using Brevis today by our partners, such as LVR reduction, like basically kind of a liquidity versus rebalancing, cost reduction by dynamically monitoring the volatility of a DAX pool. And if the volatility goes high, then your fee also directly kind of goes higher by essentially kind of dynamically and trust-freely adjusted the DAX pool parameter. And there are new type of farming protocol that can be employed, right? So today, if you think about DAX's farming protocol, is really just based on time length of the liquidity position deposit. But this is obviously not optimal because it doesn't capture the fact that who actually contributed to the protocol most. Instead, you should actually consider which of the LP position generated the most amount of fee for the protocol, in a retrospective way, to understand that, okay, this LP is actually providing real and meaningful padding liquidity for this entire protocol, instead of just relying on who provided the liquidity most for the longest of time. Because we see actually in real world that a lot of smart LPs will just remove their liquidity when the market volatility comes. So, and they will just add back the liquidity when the market volatility dies down. And this way, this type of LP are not actually contributing to the DAX protocol, but are actually harvesting a lot of the farming reward. So to make the farming reward, much more efficient, you need to redirect the farming reward based on result-oriented farming reward distribution, instead of just based on the time balance of the liquidity position deposit. There are also a very interesting, very major category that is trust-free active liquidity management. Things like, if you have a on-chain hedge fund and you're managing users' liquidity based on certain triggering conditions and certain type of algorithms. Right now, if you look at every, liquidity management solutions, active liquidity management solutions, they're all based on trust. But what we can do here is to essentially make this entire cycle, including the triggering condition and also the algorithm itself, trust-free, to say directly to prove to the blockchain that, hey, I'm rebalancing this user's liquidity position, not because I said so, but because the price range has indeed moved out of the range, and I can prove that to you. And it has moved out of the range with certain type of volatility. Therefore, based on my predefined and pre-committed algorithm, and I can also prove that my algorithm output is also exactly that. So this type of features would not be possible without Brevis. And there are a lot of other things like temporal intent-based automation. Things like if you want to have a intent executed, especially cross-domain intent executed while you're not actually actively looking and be able to assign resultant proofs, be able to assign transactions. But what you can do is you can essentially assign a conditional transaction based on certain triggering condition. And using Brevis, these type of intent-based automation solution can prove directly on chain that this type of predefined and configured condition is actually met, and therefore the intent such as cross-chain swap, bridges can be carried out based on users' intention. So this will also unlock a lot of exciting new things by expanding the time horizon where you can execute these type of intents. And things like proof of humanity, where we did with some of the partners to show that, hey, I can show directly on chain without binding to any third party that I am a pro trader by demonstrating that, hey, I have paid like more than $1 million transaction fee on Uniswap, or I have been using this wallet since like 2016. So I'm obviously kind of a real human. And things like UX personalization, where you can directly differentiating users' experience at the smart contract level by allowing these users to prove on chain that their user profile and user value based on their historical interaction with the application, with your application or many other applications, right? So if you think about it, like Web2 application today, if you open any kind of a Web2 application, has this type of feature, but none of the Web3 differentiated user experience based on the user profiles. And the Brevis will be able to enable that as well. So there are many other use cases I'm skipping right now, such as ZK bridges, ZK ML, and data-driven kind of abstraction. One thing I do want to mention is that for ABS ecosystems, what Brevis can help here is actually bring these ABS, results cross-chain, because Brevis also comes with a native cross-chain capability to essentially expand to multiple blockchains to allow other blockchains to access Ethereum blockchain states, for example. And because of that state access is now possible, random state access is now possible. Other blockchains now can, in theory, use the quorum result reached by eigenlayer ABS on Ethereum directly as well. So that will also enable a lot of interesting and powerful use cases that we are very excited about. So yeah, so that's just kind of a quick rundown of what we do at Brevis, and how we're not only benefiting from the eigenlayer ecosystem, but also will be contributing to eigenlayer ecosystem more. So yeah, with that, I'm happy to take some questions.
Thank you. That was really, really incredible. I would say I learned quite a bit. It's very in-depth, and I thought that it was just one of the better presentations I've seen. So good job. I had a lot of questions, and you started answering a lot of them as we were talking, but I might go back through and just try to clarify a couple of things. So one of the questions I was going to ask is kind of something that we dived into just a little bit just now is how can developers use it? Like what tech stack essentially would they be working with? So from what I can tell, it sounds like you have a Go SDK, a TypeScript SDK, and it supports EVM. Is that correct?
That's correct. So yeah, we
Got
have both type of SDK available.
So if someone was to like build with Brevis, are there certain networks that are supported, or can they build on any network, or how does that work?
Generally speaking, we support most of the EVM networks. With a few exceptions. So basically, like as long as the entire blockchain, whether it's layer 2 or layer 1, the block header construct is following the Ethereum-like block construct, then we can very easily support those blockchains for sure. So we listed some of the blockchains that we already have partner building with us on, but like if there are more things, we can definitely support as well.
So I'm not that familiar with asynchronous programming on chain, and I'm just curious, like, what does the flow look like? Is there basically a call, and then there's some type of callback when the data is ready? Is that kind of how it works?
Yeah, exactly, right? So like, basically the smart contract, let's say the smart contract wants to do some, computation, right? So like the first step is that you basically can write a Brevis program or Brevis smart contract. And that smart contract is, essentially kind of underlying is actually a ZK circuit. So, that circuit will be compiled and, using our SDK and tooling, and that circuit will be deployed on-chain as a verifier, as two things. One is verifier contract and the VK associated with that, basically. And with that, like your smart contract now can actually call into the on-chain portion, the on-chain proxy essentially of the your kind of off-chain verifiable computing function to say, okay, I want to do this type of computation with this input. And you can think of this kind of a verified contract as the stub basically to connect to the off-chain world. And if you call that, and the off-chain prover network will pick up on that and start to generate the proof based on the on-chain smart contract request. And once the result is generated, the result will be injected back to the verifier contract, where the verifier contract will verify the ZK proof and deliver the result using a standard callback to the application smart contract. Right. So, a very, very typical example for this is the Uniswap V4 hooks. Right. So, Uniswap V4 hooks are essentially this type of architecture where whenever you do some type of whenever you do a swap, there will be maybe a before swap hook that looks into an additional smart contract to get some logic to change the fees and all that stuff. So using Brevis, you can essentially periodically generate proof for individual users or a group of users to generate, okay, what is the trading volume for this user in the last 30 days? And that result can be right back into a hook contract. And the hook contract will be able to determine what is their VIP level and record the VIP level there. And in the future, whenever they're trying to do a swap, it will just be a very simple lookup to that VIP table, and the fee discount can be applied there. It's a very, very straightforward workflow and kind of a development flow as well.
Got it. Yeah, I was just kind of thinking about with the workflow on a client application that might be interacting with one of these. I'm guessing like you set up some type of event that is emitted once the callback is complete, and then you kind of can update the UI with whatever
that's right.
things that have happened.
That's right.
Yep.
Yep.
Gajesh, right. By the way, I haven't let you jump in if you have any questions. I have a few, but I'd let you come in first.
No worries. Yeah, I just have two questions. So, the first is like, so slashing period is fixed or dynamic? Like, is it based on like how long the?
Sorry, I couldn't hear you.
Sorry, Gajesh, I seem that I couldn't hear you quite clearly.
Oh, can you hear me now?
It's a little better.
Yeah.
Oh, awesome. So my question was, like, is the slashing period fixed or dynamic?
Later, did you get that?
Is it fixed or dynamic, the slashing period?
Yeah.
Right. So yeah, the slashing period is fixed or dynamic. So it's actually an application. So there are really two different slashing period, or like kind of a challenge period. One is an application specific challenge period, right? So that's entirely dependent on the application developer themselves. So some application developers may even set the challenge period to 0. And in these cases does exist, right? So like for example, if you want to do a trading volume based computation, it's probably okay if even if the trading volume is calculated wrong for a short period of time, that's probably fine. So that's kind of like the application level thing. But for the actual slashing, that is kind of a system-wide thing. We put that to be a very long time to make sure that even if, let's say, some application are willing to take the risk to essentially kind of inject the result soon, and there is still a way in the system side in the system level side to essentially kind of challenge that and slash the malicious or faulty node operators. So there are really kind of two different challenge periods.
Gotcha. Another question was like, can CK proofs be used to build like bridges, or is it something like just? I'll just go with that.
So not sure if I heard your question correctly. You were asking whether ZK proof can be used to build Brevis. Yeah, for sure. So in fact, Brevis is also a natively cross-chain supported protocol, right? So like right now we support Cosmos-based blockchains, state access, and also like Ethereum specifically, kind of Ethereum mainnet, ZK-like client. So the other blockchain can access Ethereum-like client, Ethereum states very easily. This is how we potentially can support cross-chain AVSs, where the AVSs are essentially kind of achieving quorum results, on the Ethereum, but this quorum result can be brought to other blockchains to be used in other blockchains applications as well by using this type of ZK bridge plus random data access that is enabled by Brevis.
Yeah, I want to add, during East Denver, we actually saw some interesting projects using Brevis to do cross-chain governance. It's very similar to basically you have the stakes or like however you compute the voting power on one chain, but then you leverage this kind of trust-free cross-chain infra provided by Brevis to leverage the result on another blockchain.
Gotcha.
Awesome.
And how do you
Any
see?
other questions? I'm sorry. Go ahead.
Oh, I know. Am I audible by the way?
I think I think I think right now it's fine.
Oh, awesome. So like, how do you see like, so with Brevis and ZK proofs, like you don't need to like have like build your own like decentralized network as such. So how do you see that? Like people moving from like building their own network of operators to do these computations to like using CK proofs or Brevis.
Well, so like as mentioned, Brevis has two different models that are both available for developer. We are trying to provide the most comprehensive trade-off plane for developers to freely choose from. One is the pure ZK model. The developer can always resort to the pure ZK model. Now, when they're using the pure ZK model, or if they're generating ZK proof in the crypto economics plus ZK model, there will be order flow generated for ZK proving, right? So like that, this is where many of the decentralized proof of marketplace will come into play. And that's kind of like an entirely different separated discussion on how mechanism design and potentially crypto economics design can work there. So for the crypto economics plus ZK, that model is always going to be there, and this is something that's going to be definitely powered by EigenLayer. So that's kind of like separate two separate models, I'm saying.
Okay, so let's see here. The question I had mentioned earlier around EVM, do you plan on supporting any other execution environments in the future, or is kind of EVM your main focus?
Right now we just support EVM, but there are definitely a possibility to support other execution environments for sure.
So you mentioned that you are already in production, and a lot of people and a lot of companies are already using Brevis. What stage are you though in terms of where you will be maybe a year from now? Do you feel like you've shipped most of the features that people want, or do you have some additional things that are coming down the pipe?
Yeah, definitely. So like, we started from the ZK data in what we internally call ZK data engine part, which is like kind of allows smart contract to have access to historical on-chain data and then do computation on top, right? So so that's kind of like the first piece we see. And there are many other pieces in this entire stack of asynchronous off-chain verifiable computing, right? So things like a very generalized computation. We're all moving towards more and more generalized computation with very powerful, pre-compiles, and also like very interestingly, we have been doing a lot of work recently in the ZKML space because we do think that machine learning workload is going to be a very important workload in the future as well. And we'll soon release a academic kind of research paper on that boosting the ZKML performance by additional 100 times. So this is something that is coming down in the pipeline. But most importantly, we do see a lot of these use cases unfold and also materialize in the next 3 to 6 months. And many of the big players in the space are actually kind of using Brevis technology stack right now, and we'll see like many exciting features launch along that line as well.
Okay, last question about Brevis specifically is this. So you mentioned that developers don't need to understand ZK circuits to use and build with Brevis. Do they need to understand ZK proofs or ZK technology at all, or can they essentially just leverage the abstractions and the SDKs and APIs that you all offer, and most of that is just done for them?
So I would say like they just need to understand the ZK concept, right? So like basically that's something that we do need developers to understand. This is how we can they can understand like this is the reason that the entire workflow is actually trust free, right? So why a off-chain computation done not in any of the blockchain construct can actually be trusted by the smart contract. So that is the key piece that the developer need to understand. So and then they need to understand like this asynchronous design pattern as well. But in terms of the ZK circuit building, they don't need to understand any of that. It's just a kind of almost like a very simple to use API where they can just like manipulate data on top. So they don't even need to worry about anything about ZK in general. There are some very very minor kind of nuances that is exposed in the SDK layer, but it's like very simple to remember, like such as like you need to specify the max amount of data you want to process. That's pretty much it, right? So like that's the
I want to add a little bit. So the API was designed to let the developer just express their intent. So basically what they want to achieve, what kind of the data they want to deal with. So the underlying the internal ZK circuits is handcrafted by the Brevis team. For I would say a developer to start integrating with Brevis, they definitely do not need to be aware of any of the fancy math the ZK depends on, right? The curve, which curve you pick, and what are the prime field, and all the thing already handled by the underlying SDK and the Brevis infrastructure. I think if the developer, but of course, from another perspective, it never hurts to learn more about this domain, right? And if they really want to push the limit, like the Mo mentioned, like the number of data points, right? How many the maximum data points the app can handle, and things like that. They might want to say, oh, why there is that limit in there? Then they kind of get to dig deeper to understand because of the underlying ZK circuit and all the constraints we have to live with.
So I guess one last question there. And this is kind of, I guess, developer related in terms of the use cases that you mentioned. And you mentioned off-chain. Can people build with arbitrary off-chain information? So, for instance, you might want to prove like the score of a football game or something like that. Can stuff like that be done, or is it mainly aggregating on-chain data and then bringing it back on, taking it off-chain, aggregating, and bringing it back on-chain?
Right. So like right now, as I mentioned, like we're expanding to the stack, but right now for the data engine that we build, it is very much focused on on-chain data access because we see this is where the demand lies most because right now smart contracts they are just basically blind. They can only see the current slice of time and they can only see very limited things in this slice of time that is only available to like publicly accessible functions and all that stuff. So we actually did accumulate a lot of very very useful data in the past that is just not be able to be used in the smart contracts. And using Brevis, we can at least let that part be handled well. And in the future, as we generalize the entire computing stack with integration or building of the ZK VMs, this part will become like this part of arbitrary off-chain computing will be possible. But there are a lot of nuances about bringing off-chain data to the on-chain world. Like, what does that even mean, right? So, do we authenticate the TL's signature? Do we authenticate something like that? So, but I do like the intersubjective architecture for eigenlayer, which is like because I have been around for a very long time. I know from the very early prediction market days, and I think like the intersubjective architecture definitely solve a lot of issues that didn't get solved in the early prediction market days. So I think bringing generalized off-chain data on-chain, eigenlayer will be a very useful tool on that aspect as well.
Awesome. So we're getting close on time, but I want to touch on one more point. A lot of people are building AVSs or they're exploring building AVSs and they're dipping their toes into the ecosystem. Do you have any advice for people that are looking to build an AVS based on what you all have learned? And I know you've been building since the early days, so things have changed a lot. But let's say someone to build an AVS today, what would you give them like in terms of advice?
Well, I think first of all, I would say just read the documentation. The eigenlayer documentation is really top notch. It's really kudos on that for your team, and it's very easy to follow and it describe things in very detail. I would say like definitely focus on that, and also like there is a very strong community. Because a lot of the folks have been building on eigenlayer, and there are eigenlayer developer groups, and if you're interested in building AVS, definitely join that group. Just ask questions. Everyone is pretty helpful on that as well. On the more technical side, Junda can provide some more insights as well.
Yeah, I want to add, both the on-chain and the off-chain components. Our on-chain smart contract when integrating with eigenlayer, because the core contract from Eigen already handle most of stuff. Our smart contract was so simple, that it's just like I would say the audit firm said, "What's this?" There's no need to audit. It's so obvious.
Nice.
Yeah, I think that kind of tells the team, the Eigen team did a pretty good job, right? Especially from the on-chain and smart contract perspective for all the complicated BOS signature handling and everything. As the AVS, we don't need to worry about it, right? Basically, we get this and we throw it to the BOS APK, the signature verifier, and we're done. I think that's really nice. And also for the off-chain, because you still need the operator to run something, right? Basically to help secure the network. I think the building blocks provided, I think we have been familiar with Go. I think the Go Eigen Go, I kind of really enjoy using that. So I think that's really, that's why kind of I would say from the idea to the first prototype only in a couple of days, right? So basically it's really quick. And also down to the production, you have to think more from the security perspective, right? How do you make the onboarding of the operators more smoothly, right? So I think that's kind of down to the easy for the operator to join and also day-to-day operation. And then on the other side, how do you monitor the overall health and the system operation status? Now you actually have, I think we have more than 70. I forgot to count how many operators we have now, right? So basically it becomes suddenly you have to manage relatively large operator networks.
Well, this has been really insanely useful. I think me and Gajesh are about to go hack on some TypeScript with Brevis and do some open source. So this has been really cool. I honestly didn't even know you had a TypeScript SDK. So really happy to hear that, because that's the language that I know the best. So therefore, I usually am more likely to just pick up something and start hacking on it, because it's just a lot easier. But if anyone is watching and you want to get started with Brevis, you can go to brevis.network. You can also follow us, Brevis_ZK. And you can go to my Twitter/Dabit3, DABIT 3, and you can see a link to follow both Mo and actually, Junda, I don't know. Do you have a Twitter account? I wasn't able to find you.
It's
share
just
that
my
with me.
name at Junda, but it's more personal.
Junda, wow.
It's more personal. Yeah, so you will see I follow some games I played.
Okay,
nothing to do with work.
Okay, well, if you want to follow and learn more about Brevis, probably follow Brevis ZK, then and that's where the stuff is going to come from, and me and Gajesh as well. Follow Build on Eigen. That's our new developer-focused Twitter account. Thanks so much, guys. I appreciate your time. I know you all are busy, but this has been really great.
Thank you.
Thank you, Nader, for the kind invite. Thanks. Thank you, Gajesh.
All right, so we'll be back hopefully next week with a new Infinite Layers. So thanks for stopping by, and we'll see you next time.